What is up everybody, I'm 𝐤𝐳𝐬𝐿 Dashura and I'm back with a video and some new learnings. In this video we are going to see how do we do the simple and multiple linear regression analysis in Python. We'll be using a library called Statsmodel to do this task here. And but before starting this, I would like to have a small request. If you have not yet subscribed to my YouTube channel, then please go to my YouTube channel and subscribe it, and also hit on the bell icon. Also, if you want to get a free access to my Google Drive, where I save all my all my codes, including the code that I'm gonna write in a few minutes, you can go to my YouTube channel, and after subscribing, just click on this button, which is access to my Google Drive, and then it will redirect you to a Google Forms link, and then you just need to provide some basic details like your full name, email address, etc. And I'll be using this email address to give you the access to my personal Google Drive, and I save all my codes there. And there is no copyright issue. You can use any of those codes for your personal uses. It's free for everyone, but the one and only condition that has to be valid is that you should be my subscriber to the YouTube channel. Anyway, so let's start with our task, which is the simple and the multiple linear regression analysis. In order to do this task, I am using housing data, which I got for free on internet. I will save the CSV file, comma separated file, on the Google Drive, and you can download this file from my Google Drive, and then you can also practice it on your own. Okay, so let's first of all read this CSV file through pandas library. So import pandas as pd, df is equal to pd dot read csv, and then housing dot csv df dot tail. So we have this data of the housing data. Actually we should do index call is equal to 0. Perfect. So we have this index, and then we have 5 different parameters. I don't know what is the full form of these 5 different parameters, but I'm just using it for the regression analysis. You can do the same analysis on stock prices as well, but I found it easier to do it. That's why I'm just using this one. The analysis would be exactly the same for any type of data. Here I'm using housing data. So let's start with our model, and as I already mentioned, I'll be using Statsmodel in order to do this regression analysis. There are number of libraries for regression analysis, but I like this library more because the summary that we get after doing modeling on this library, it is quite helpful because it gives us many parameters like R-square, adjusted R-square, and the complete ANOVA table. And the summary analysis of different other libraries is not that much helpful for me. You can use those as well if you want, but I found this one much more useful. So let us start with this library. So import statsmodel.formula.api as smf. Now let's start with our model, which is model is equal to smf dot OLS, and the first parameter is formula. So we can do it like formula is equal to, and actually there's no need to write formula is equal to this. So the first parameter is all the dependent and independent variable that we are considering for our regression analysis. In this in the simple linear regression analysis, I'm just considering these last 2 parameters. So rm and then medv, using the data of df dot fit. It's as simple as that. So our analysis is done. Now in the regression equation we know that we get two parameters, which is the first one is the intercept of the regression equation, and the second one is the coefficient. As we have just one parameter here, one independent parameter here, in order to get the dependent parameter of Rm, we will be having just one intercept and just one coefficient. So b0 and b1, b0 is equal to model dot params and then 0 and b1. This is how we get the intercept and the coefficient through this modeling. So the value of b0 is 5.08, the intercept, and the value of b1, which is the coefficient, is 0.053. Now in order to predict the value of Rm, we can just write a very basic equation. Actually there are two ways to do it. One is to write the equation and then do the prediction, and the other one is quite easy. I'll tell you how to do it in an easier way, but let's first write the equation first. So prediction, let's do 1 is equal to the equation is b0. I am quite sure you would be familiar with this equation, which is b0 plus b1 multiplied by the parameter, the independent parameter, which is in this case dfme dv. So you can see that the last 5 values of the prediction are of these, and as I already told you, there is an easier way to do it. We don't need to write this equation, and in fact we don't need this b0 and b1 through that, and we can do it like this, which is, let me do it, prediction 2 is equal to model dot predict, and then just provide df prediction 2 dot tail. So we can see that the data is exactly the same, so we don't need this one. But still, for you guys, I'm keeping it in the code such that you can use it in future, because I assume that you will go to my Google Drive and then you will download this code. So actually I should put it for you guys the first way, and then second way, just for you guys. Okay, so we have got our regression equation. Now what are the next tasks to do? What are, I would say, before going to the multiple regression, what is the next task to do? Actually I think that we should include the predicted values column here and the error column here, in order to get this in order to get a comparable data on just one table. So df response is equal to, what was the formula? It is basically this one. And df error is equal to df response minus df rm. Perfect. So we have got two different columns of response and the error term, which is response minus rm. So now we can visualize it by plotting it, and in order to plot it, I'll be importing the most useful, not useful, the most widely accepted plotting library, which is matplotlib. So import matplotlib lib.pyplot as plt.scatter. On my x-axis I have df me dv. On my y-axis the actual data, which is rm for now, and then let's do plt.show. So you can see that this is the actual data and our regression line should be somewhere like this. So let's check plt.plot. The x-axis is the same, which is dv, and our y-axis is now df response. Let's make the color is equal to red in order to make it visible. So perfect, we have our regression line, which is quite good, I would say, because we can see that it is following the trend as per the scatter plot. And I would say the better analysis would be if we see the error term also. Like the error term should not deviate from 0. So let's do plt dot actually scatter only, scatter, and then error term is x-axis is again the same, dv, and then error term is df. Error term, you can see that this is the x-axis, which is 0 line, and most of the data is very close to 0, which is good. The error term should be close to 0 only, but we can see that there are some data points which are very far from 0, but we cannot do anything here. This is the best regression line that this model has made. And if we actually draw a line, draw a scatter plot between the actual value of RM and the predicted value of RM, and if we can, if we see any correlation, like a very good correlation between both of them, then I can say that the regression analysis is quite good. So plt dot scatter, on base we can put anything on x-axis. So let's put actual data on x-axis, which is RM, and then on y-axis let's put response. We should see quite good correlation between these two variables. We can see that it is quite good. As RM is increasing, our prediction is also increasing, so our analysis is not that bad in this case. And in order to get the summary data, in order to get the R-square data, adjusted R-square data, ANOVA table, there's a very easy way to do it, and this is the reason that I use this library, and I love this library a lot for regression analysis, which is model.summary. We get a lot of data here. So this is the ANOVA table. This is the coefficient, standard error, the t statistics, p value, everything is here. We also have Durbin-Watson's stat here, and then R square, which is 0.484, which is 48.4%. It's not good, it's not great here, because it's less than 50%. It cannot be considered great number, but still, if we do this analysis on stock prices, and if we get R square of 48%, then it would be amazing. But on housing price, it's not that great, but still it's good. So we can see that we have a lot of data here, and we can see the skewness, the kurtosis, etc. So there's a lot of things here. So model.summary is quite good for our analysis. Now let's do the same thing. Let me check if I have skipped anything. I think I've covered each and everything here. Perfect. Now let's do the same analysis for a multiple linear regression. The only difference between multiple linear regression and the single linear regression is that rather than just one variable, one independent variable will put plus, and then LSTAT plus indus plus NOx. That's it, and then we'll fit it, and then we don't need this one. We'll do the prediction here again. We can see that these are the prediction. Okay, let's make it here. We can see that the error terms and response are updated, and Okay, the regression equation here is very weird because we are taking multiple regression here, and this is 2D plot. But still, we can see that it is quite like good. It is covering the entire plot. If you do it scatter, we can see that there's very good correlation between our predicted, I would say, our regression equation and the actual data. If we do the error analysis, we can see that there are more data that are close to 0. So I think our regression equation has got better. If we do this analysis, there's very good correlation, but the best thing to do here is summary, and we can see that our R square has increased to more than 50%. Now it's 51.4%. R square is basically the explained variation, the explained variance by the model. So the high number is better for the model. If it's more than 90%, then we can say that more than 90% of the variance is explained by the model, which is quite good. In this case, it's 51.4%, not great, but still it's better than the last one. So we can we have done both of the analysis in order to do the simple linear regression analysis. You just need to delete this one and do it. If you are doing the multiple analysis, just put plus 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 and put all these variables. It's that easy. That's why I like this library a lot. So I think I have covered everything in my notes. Perfect. I hope you like this video. If you like it, please click on the like button. If you want to share it with someone who is keen to learn all this stuff, then you can please share it with your friends. Don't forget to subscribe to my YouTube channel, and if you want to get access to my Google Drive, I will mention it again. You can go to my YouTube channel after subscribing, click on the get access to my Google Drive button, and then enjoy all the codes for free. Again, thank you so much for watching my video. I hope you liked it. Stay tuned.